Hello everyone. Pleasure to be here, and welcome once again to another community call with Memgraph. You can definitely see the familiar faces from last time. So we had Doug and Satya from Previsant do a live demo last time, and this time we are diving into the payments and basically the fraudulent kind of aspects of it. So basically, there's a lot of kind of improper payment detection or the payment detection of kind of improper payments, and it depends on understanding various payment rules and various basically rules in generals, and those rules are usually buried in thousands of complex inconsistent documents, and we're gonna see the guys will walk through us their payment integrity platform to basically instruct those rules and model them as entities and relationships as a graph. So without kind of further ado and basically taking the spotlight, I'll hand it off to Doug and Satya, who will walk us through it. If you have any questions, I think last time it worked really well in terms of kind of the fluid kind of question and answer that we did. So if there's any questions, feel free to post it in the chat, and we can basically respond kind of in real time and take it from there. Having that said, the floor is yours.
Perfect. Thanks, Marco. Good morning, everyone. And yeah, we're gonna Satya will bring up the PowerPoint here real quick, but essentially we're going to talk through, as Marco said, our payment integrity platform, and the idea of graph database and Memgraph in particular is really key given the business problem that we'll talk through here in a sec. But the foundation or the fundamental is that the way that our senior healthcare system works, it's called Medicare. And if you're not familiar with it, it's once you turn 65, you are then eligible for government-sponsored healthcare. And there's a government component, and there's a thing called Medicare supplement that pays for the things the government doesn't pay for. And the way that's administered is very heavily based on unstructured data, which is different than the way it is for commercial if you're just, before you turn 65 and you're part of a company. So the problem is how do you work through those rules? And that's what we'll talk about today. Satya, if you can go up, we're actually on the demo panel. We need to go all the way up. Sorry.
Oh yeah, sorry.
No, that's my fault. I left this in the wrong spot. So yeah, what we'll do is we're just going to go through a really quick introduction and then talk about the business context, the context we were kind of talking about, and a quick overview of the platform, then go into the demo itself. Satya will show some of the features with real questions and how the responses work, etc. And then we'll have the opportunity to kind of talk at the end with any Q&A. And feel free to ask him. I can see the questions roll up on the right-hand side of the screen. So if you want to ask during the presentation, that's fine too. So Satya, let's go forward. So very quickly and we failed to kind of do this last time, but a very brief overview on who we are. Satya and I are co-founders and part of a larger team, but essentially both of us come from both consulting and client-side roles over the years. And at this point, I think we're both on the wrong side of 35 years of experience in industry. But what we do is focus on healthcare insights to begin with, and that's really the platform focus. But we also complement that with strategy and enablement, meaning strategic data and analytics, machine learning and AI consulting. And then we also do a level of advisory and mentoring or virtual leadership as it's needed. So we just wanted to give you all that perspective of primary focus on the product side. We're product led, but then we still do a fair amount of strategic consulting, not just the strategy piece, but also getting into execution. What should the architecture look like, etc. And that's essentially who we are in a nutshell. So go ahead, Satya. Yeah, so the context here, as we said, the big problem we have is with both fraud and waste and abuse, and we characterize those together, but there's one side of the problem, which is truly detecting fraudulent providers who are not real, but they set up storefronts and they will dupe the government and create additional payments that should never have existed. That's one side of the problem. The other is waste and abuse, where we have upcoding, improper payments, intentional or not. And both of those represent a really big, significant fraud, waste, and abuse tax that ultimately impacts the insured, the people who are age 65 and over, and particularly as they're buying a Medicare supplement product, it really impacts affordability. So that's a huge piece of the problem that we're trying to solve. Also, if carriers find it difficult to not lose money, then that continues to drive up costs, which tends to have a huge negative effect on sustainability of these products, these private sector products that complement the government's Medicare products themselves. And we won't go through the foundational assumptions here. These are more for our practitioners, the special investigation unit folks, or people that own a book of business. But there's some foundational assumptions that have been interesting. And I think the lesson learned here is that to get value out of any solution, we have to consider people and process, not just the technology. And I think that's part of the piece here too, is getting organizations to realize that if you are a secondary carrier, part of the private sector that supplements Medicare, you do have some autonomy and the ability to challenge improper payment. So that's a big piece of the context here. And we talked about this a little bit, but the next panel talks about affordability, improved customer experience, and obviously the optimized performance and ROI if you're a carrier. This extends this happens to be a Medicare and healthcare insurance problem, but you can think about fraud, waste, and abuse in any industry that's, whether it's retail, banking, there's applicability for needing to drive out excess costs because it ultimately negatively impacts your customers, your clients, your operations, et cetera. So there's a number of stakeholders that are potentially negatively impacted here. And I just think the other piece we noted is there's a residual benefit of improving customer experience. People don't like to be involved with fraud, and I think that was part of, they don't want to have their identity stolen, payments to be defrauded, et cetera. And initially there was an assumption that, hey, we don't want to bug the customer about this, but what we found out was something very different as part of the process of standing these capabilities up, which is an interesting side note. Let's keep going, Satya. And again, we won't go through that. We won't go through this in detail, but I think as we talk here, we're going to double click on the solution on the right. And the compare and contrast here is if we're thinking about fraud, meaning the people who are strictly fraudulent, they may be in the US, they may be somewhere else, but they're not really legitimate providers. The technique there is a more traditional machine learning capability where we just train a model on known fraudulent capabilities and continue to find that over time. However, on the right-hand side, the waste and abuse, which may or may not be post-payment, we may catch these before or after a payment's made, but that's really the process we focus on here. And it's very different in the sense that we're using AI, natural language processing, graph database to really understand how do we get the rules out of this unstructured data and create a data asset that allows us to test whether a payment is valid or not at scale. And that's really the piece on the right is what we'll double click into, but we just wanted to show that heritage from the broader context into, okay, now we're really moving to this rules or knowledge extraction problem that solves the downstream waste and abuse problem. Satya, go ahead. And then I think, and there are a couple of animations here, but again, to another level of detail, if we look at our source documents, we get information that obviously contains the rules in the form of source documents. There's also related information about providers, reference data around codes, our procedure codes, our diagnosis codes, et cetera, as well as the claims themselves. And those are all input into the knowledge extraction process, which is there in the middle. And Satya, if you can click, we just have a couple of animations here. So there are roughly 2,000 coverage documents that we bring in, which result in several million rules themselves. But the key piece here is the graph database enablement is that relationship between, not just the rule itself, but relationships between rules. And as you can imagine in healthcare, there's a lot of complexity, a lot of network interaction between procedure, diagnosis, or diagnosis and procedure, because we're dealing with a holistic, obviously human, right? That where the healthcare is being performed. So understanding the relationships across those rules, how they pertain to a particular case or a claim line, that information across is what's really being enabled by the graph database. Ultimately, then the way we make this actionable is, as we talked about, we have knowledge assets, including a vector database, graph database, that gives us the ability to, at scale, understand what are the improper payments, what are the flagged claims that need to be followed up on with explainability. And I think there's a call out here too for the graph database enabling. It's not good enough to say, hey, this was wrong. You have to be able to explain what was wrong. You have to be able to rationalize that back to a provider that may have done it incorrectly, likely by accident. So that explainability component here is really key. And then we're just illustrating a call center application where, again, if we're doing a natural language interface, the ability to navigate back and forth is a part of the ecosystem as well. So Satya, go ahead. I think that's a fair amount and probably what we wanted to talk about from just a pure context perspective. And from here, I'll hand it to Satya and Satya will talk about the actual technology itself.
Yeah, thanks, Doug. I think as you mentioned earlier, I mean, we are using several technologies here. There are 2,400 documents that Doug talked about, which are in PDF files or CSV files, as well as some text and web content. At the same time, we bring in claim records, that need to be identified for fraud or for waste and abuse. And you can imagine claim records are structured data, and whereas the rules are in the unstructured PDF documents or other types of documents. So what we realized was that we have several technologies here, because most of the relational data existed in relational databases or CSV files, and all our unstructured content, the rules, the coverage policy documents, they are all in graph database. And now the reason we were using graph database is, as I think earlier pointed out, it helps us to understand conflicts and overlaps among rules from different articles or different documents. So one document may actually allow a particular claim with a certain diagnosis and procedure combination, but another document may put some additional conditions on top of it. So we need to make sure that Article 1A and Article 2, how do they conflict or overlap for a particular procedure or diagnosis code on a claim record. So what we have done is we have tried to bring in different technologies like graph database, Gen AI, MCP, which is a model context protocol for communication among all these components, and then AI agents for various tasks, and then in the end, not but the least, is the relational database. So we have brought all these things together in a one seamless platform, which we call as adaptive intelligence platform. Using this platform, what we realized was, while it was helping us for our waste and abuse discovery from the healthcare claims, but we have also been able to use it for a knowledge graph discovering ontology across different domains. And this is the application that we, I think, demoed 2 weeks ago in our previous webinar. And then at the same time, we have been able to build cross-system lineage, end-to-end lineage across different source systems as data travels from the source systems to the target analytics environment. And what we are realizing is it has several more applications, including AI governance, as well as PHI scanning, healthcare scanning, and making the data not visible to everyone who doesn't need to see that data. So this is the application that we are going to demo today. So it has 4 different components. The first one is, of course, document and claim data ingestion. And for documents, as you can imagine, we are using, because we need to store all the documents in chunks, so that earlier Doug was talking about explainability. So once, based on the rules, if we find out that a claim is to be denied, then we need to show the reason. And for that reason, we need to go back to that actual document and bring out the text of that document which denies, or based on which we deny the claim. So that is a very critical point here, that we are using the graph database, Memgraph, to be able to store the relationships that helps us to discover conflicts for a given rule across different documents, and that helps us understand which rules are mandatory in nature, which rules are suggestive in nature, or which are recommendations, or there are certain things that are completely prohibited. But at the same time, why these things are prohibited or are mandatory or are recommendations, that text and that information is stored in a vector store, which is more optimized for storing actual chunks of the unstructured data. And Memgraph especially, is excellent at storing relationships and among different documents, and even helping us in identifying which of these claims are supposed to be bad claims, so to say. So there are 2 types of stores: the vector store for storing chunks of documents, and then the graph store for actually storing structured and even unstructured data both. And the 2 screens on the right hand side, basically it will show you how it works. And then there are 3 query modes. One is the RAG mode, which is basically querying information from within unstructured documents. So we have an AI based chat interface which helps you select one document or multiple documents. So you can say, okay, go find answer from this document only. Don't use your general intelligence, so to say. Because otherwise, hallucination can be a big problem with Gen AI. So this is where we have brought Gen AI and our unstructured content together along with graph database. And then we have a chat interface for graph database as well. So in that case, the query just goes to the graph and brings information about the relationship stored in the graph database. And the third mode is, which we are calling as hybrid, but people also call it graph rag, where it looks at the content from the unstructured document and matches it with the content from graph, and tries to bring you an accurate information together. The second is the rules and audit engine capability. So the first part here is, we have, let's say, ingested all our documents, 2400 documents that Doug alluded to, in our vector database and the graph database. And from here, now we try to extract different kinds of rules. So for example, we have medical necessity rules. That means, is this procedure necessary for this kind of medical diagnosis? And the billing type of rules. And coding is the way they have coded a particular diagnosis or procedures. Are they properly coded? Or they, the right diagnosis goes with the right procedure kind of things. And then duplicates among claims and procedures both. So we have an opportunity here to not only extract rules, but then analyze them. What kind of rules are they, and review them so that we have a human in the loop who is an expert and who can look at the rules and see if all these rules make sense, and then we can fine tune. We can, fine tune the rules, adjust the rules, or take the rules out based on what we need. And then the last piece of the application is the audit engine, which basically uses all the rules that we have extracted against the claim data, and then find out which are the objectionable claims, along with a dashboard example that is shown on the bottom. So this, in nutshell, is an overview of the application, and I have a couple of more slides that talk about the overall architecture, just to explain. So we have the documents coming in, then we have the ingestion engine where we are using LLM to extract along with the fast API for user interface, then the vector database, which we are for the time being using ChromaDB. And under the hood, we are also using a nomic embedding model for basically breaking down the document into smaller chunks, as well as the verbs and nouns and adjectives out of the text. So we use 2 or 3 variations of embedding models, including sentence transformers. And then we store the rules that are extracted into the actual graph database. So we have 2 types of stores, as I mentioned earlier. And then we have the LLM layer that can then help us get either the RAG query, the graph query, or the hybrid mode. And at the bottom, we show all the technologies that are being used. And on the LLM layer, we provide option for different types of LLMs, whether they are open source like OL Llama based models, as well as Anthropic, Azure, OpenAI, or any other model that you want to use. And here is a basic slide. Basically, it shows, and I think now it is clear that why we should use graph and RAG both, because RAG is used for storing content of the documents, whereas graph is used only for storing relationships among various entities. And our key entities, for example, are a provider of healthcare services, or the procedures that the provider performed, or the diagnosis for which the procedure was performed, and what is the rule, and that's another node. So those are the kind of examples of nodes. And in the application, we have a provision to actually define your schema for the Memgraph database. And based on that schema, we extract the rules. So with that, we are going to get into the demo. I will have to get out of this mode. So let me. So Doug, can you still see my screen?
I can. Yep. Looks great. Looks great.
So here is the application that I was talking about. So as you can see, it is currently running on our local host, and it's a very easy to use interface. I'll just walk you guys through our various aspects and components of this. So the first screen that you see here is the screen where we can use it to ingest document, either one document at a time, or we can ingest a bulk load capability. So we have the bulk load. We can have a CSV file, we can append to the current graph, or we can generate a brand new graph. And when we say generate brand new graph, it will wipe out whatever is already stored in, and rebuild everything. And when we say append, whenever there are changes to documents, we simply append them. And we have capability to clear the graph or even show the loaded documents that are there. The second piece here on this first screen is the schema configuration. And this is very critical point. This helps us identify what are the things that need to be stored in the graph database. So, for example, this first screen here is what entities, like, as I was earlier, what medical article it is, and it will store various aspects of that article or look for that information. And then CPT code, which is our procedure code, and what are the diagnosis codes, medical necessity rules, code groups. So these are the various nodes about which we will extract information and store in graph database. So this is where you can define and actually save the schema. So you can make changes, you can validate, you can save, and it is stored in JSON formats at the back end. And then you can look at the relationships, what are which relationships do we want to pick up. For example, this procedure code covers the following diagnosis or things like that. So this is like a data model for the graph. And then here are the synonyms where we can say procedure code is the same thing as CPT code, is the same thing as HCPCS code, and things like that. So because there could be various names being used for the same entity across different documents. So this helps us bring all these things together and help us discover the conflicts which we earlier talked about. And then here at the other side of this, we have the rules management, where we can see how to fine tune the discovery of rules. So these are the prompts that are used by the system to uncover rules from within those unstructured documents and store them in the graph database. And then we have at the bottom, summary of what are the rules and how they were discovered. And then even our business expert can actually look at these rules, or we can even create a new report that goes into a Excel format. And this is the third piece, which is the claims ingestion engine. Here is a capability to ingest millions of claim records. Currently in this, for this demo, I have 1007 records loaded, but we have tested it with millions of records. And then this is another critical piece for configuration and connections. So this one helps us to set up things about the Memgraph database, where it is stored, what port it is available, what is the user ID, password, the Chroma database, which is the vector store, and the LLM. We could have Azure OpenAI, OL Llama Local, or Anthropic code, and then which embedding models do we want to use. So these are the various structure document structure configuration capabilities that are available. And then here we can, once Memgraph is connected, it will show it is in green and so on and so forth. So before I go ahead and we show you actual querying capabilities, I wanted to quickly show you. We have 1007 claims ingested, and when we say find the claims that are to be denied, it comes back with a dashboard which shows out of 1007 claims, 5 were denied, 1002 passed. There were 26 rules that were used, and here at the bottom it shows you which claims were denied and what was the reason for those denials. And Doug, now we are going to go back and probably show some, here is what it shows when, we load the documents. It shows you the log files, what is going on.
Yep.
And then this is the AI powered query interface, which has the rack capability, as I mentioned before, the graph capability, and the hybrid capability, and the standard reports that we have that we can generate out of graph. And then you have the capability to select one or multiple documents. We can deselect all, we can select them all, or we can select one or multiple documents. And then at the bottom shows currently which model is being used, and then here comes the response from the documents. And then at the bottom we have capability to actually go to Memgraph lab and see the results. For example, we can see here actually the nodes that are loaded in the Memgraph database currently. And then here also you can exit the uh, screen, and you can use Memgraph's UI to browse through the graphs as well. So multiple ways to look at your graph, as well as to actually query the graph and run our audit engine. So Doug, we are going to go through our standard questions. You want to go
Yep.
through, or
Yep. And I think the first one we're going to poke at, Satya, is what are the documentation requirements for billing? And in this, so the way, again, the background here is we have documents, and this one happens to be A57185, but it's about botulism toxin or Botox. Just happens to be one we use fairly typically. But yeah, Satya is going to put that in, and then we will get a response back from the query to understand, what is that particular answer? What are the documentation requirements? And again, if we think about that, the context here, the persona that would probably interact with this could be the person that's actually in touch with the provider to kind of follow up and ask on this, or it could be an SIU persona that's trying to understand, hey, if we had these 4 or 5 rejected, why? Let's do some more research into the explainability as to what went on. Right? And Satya, you have that response up, but I think they're fairly detailed, but it really gives 5 or 6 basic reasons for what the problems were. So it's talking to medical necessity, talking about documentation must include, repeat injections must show evidence of prior clinical responses, etc. So it really goes into some detail within the doc to say what specifically needed to be in place to answer that for that specific question. Right?
yeah, this next question is graph related, Doug. So
Yep, and then the next one is find all rules associated with procedure code 64612 and list the diagnosis groups required for this condition. So that one has, go ahead, Satya.
Yep. So it shows you.
Yeah, and really, it's really calling out, I think, 3 rules: paralytic ptosis, spastic hemophilia. By the way, I'm not a doctor, so I'm not going to pretend I can't understand what these things are, but it's really important for the SIU person to hemophyseal spasm, facial dystonia diagnosis requirement, etc. So again, a fair amount of detail, and then we can also, in practice, you could also do follow-up queries with that to further summarize, like you would see in any LLM. So that's a.
And here one more thing, Doug, I want to point out is whatever question we are asking, it converts those into a Cypher query actually, and then even the data wise. So for example, at the bottom it shows you all the data in actually JSON format, and you can use it in whatever for whatever other purpose, and export it. So
Yep.
let me show one more question, maybe.
Yep, that's perfect. And I think you have, can we show the rules with the prohibition modality, meaning if we
Yeah,
have a strictly prohibited case, what does that look like? Again, you have this is a hybrid query, Satya, but and this is one I think again is a really good example of how it's stretching across, because we're talking about a bilateral modifier is prohibited for two specific CPT codes or procedure codes, and then it lists a number of other ones. So it gives us the opportunity to see how these things interact with each other, potentially within an article, but understanding those relationships is really key in this example as well. I think it's
yep.
fair. So again, that's the did you have a fourth you wanted to do, Satya? Are we good with those three?
Yeah, I mean, I think, yeah, we can do another one. Yeah.
Yeah, I think another one would be, is this the medical necessity for diagnosis of
Yeah.
EPT? Yeah, and this one it's fairly complex, but this one is interesting in that it gives five different. If we summarize up, it really is getting up to five different situations, talking about a CPT or procedure that's medically necessarily only when billed with approved ICD diagnosis codes. Talks about what the covered indications are, migraine,
Yeah.
et cetera, et cetera. So it really, without reading through these, it gives the persona, the consumer, the opportunity to really dig further into, okay, can I confirm that the conditions described here in the rules are consistent with what we have, and further dig into a conversation that you want to have with a provider. And our vision here too is, and the way it's actually being used is that these can be real-time interactions with a call center or an SIU person that's actually on the phone. So that's part of the feature here of uncovering this complexity, bringing some structure to a relatively unstructured world, and then really being able to action on it and get to the bottom of what is going on here and how can we, as we talked about early on, how can we drive this fraud, waste, and abuse tax out of the environment?
And I think the way this application has been designed, I mean, as I earlier mentioned, I think we can even look at what is actually stored in the vector database, and what is actually stored. So there is complete transparency about, the whole application, and it helps us dive deeper into whatever result come out, and we can say why we got the result that we got.
Right. Exactly. Back to the explainability concept,
Yep.
right, Satya? That's so critical.
Yeah.
And that's kind of that's a theme in analytics, data science, AI in particular, governance. It's just the explainability factor is absolutely critical. And I believe everyone here on this call, I'm sure, understands that very clearly. But it's just another thing we are always aware of, not just from an audit perspective, but it actually guides behavior on the back end. If you're an SIU person that sees that these are the reasons for a problem, it can save time in target investigation. So it's not merely an academic auditing exercise. It actually helps drive, efficiency as an SIU, special investigations person is navigating through the ecosystem as well. Satya, I think the last panel we had here was just some additional thoughts on, further afield, or where else could this be applied? And I think last time we connected, we talked about this in a P&C context. So we were kind of staying within the healthcare swim lane. But last time we talked about property and casualty and potential application for private equity, really anything where you have a lot of text, a lot of unstructured data, and you're really trying to make sense of, inquire against it, apply rules, etc. So these are just some examples. And again, this is more of a leave behind. One of the big topics for U.S. healthcare, anyway, it's not just the fraud, waste, and abuse piece, but how do we make sure that the cost is being delivered as effectively as possible? Because here, frankly, we do have a problem with, as you may know, we have a problem with exploding healthcare costs that are really outpacing inflation year over year and have for a long time. So a number of these really deal with how can we ensure that we're not having cost amplification, issues with prior authorization. The fifth one down, called clinical knowledge graphs and explainable AI, that one is very interesting as a broad theme in terms of, again, if we expand beyond just the use case we're talking about, there's this whole universe of disparate, disconnected clinical data, policy data, claims guidance, et cetera, that really makes administrative cost difficult. So if we can use that to streamline administration, that can be very helpful. And again, try to get costs under control. And the sky's the limit. We just came up with several here, but I think there are, our thinking is, and our point is that there's the graph database enablement is really key to trying to solve this problem globally. That's a real problem here in the States for cost containment, cost optimization, affordability, sustainability, et cetera. Whether we're talking about Medicare and care for seniors that is driven by the government, or private sector, as you're still an employee working for a group that's either self-insured or employed by one of the private insurance carriers, et cetera. These are still really important considerations for quality and outcomes within our healthcare system. So, enough said.
Yep.
So with that, happy to take any questions, comments.
I think I don't see any questions. If there's any questions, feel free to post them in the chat below. Yeah, maybe a question from my side, like, what are the kind of most, like, you were talking a lot about kind of explainability and kind of traceability, auditability kind of to it. So what are kind of the main points when it comes to actually kind of choosing the platform and kind of the way you would work? Like, what are the main reasons why people, and what are the kind of maybe the industries as well that are really looking into that?
So the drivers for this kind of capability overall, Marco, so it's a great question. I mean, ultimately it gets back to that cost thing. So if we have a 13% tax, 9 to 13% of the claims that are coming through should not be paid, it means there's significant leakage. So we're just leaking oil at the end of the day, and there's money going out of the system to either a truly fraudulent actor, a bad actor, and that money's never coming back, or it's going out to a potentially a bad actor on the provider side, or more likely just somebody making a mistake. But in any case, without trying to assume intent, that's the problem you're trying to solve. That's the driver. So if companies are, and the secondary payers, by the way, really bear a huge burden. The government may know that things are going on, but they can't share because of due process. So the secondary carrier, that directly impacts the consumer, by the way, because you pay out of pocket for a secondary policy to cover what the government doesn't. That's the other driver, because if they get price wrong, if they're paying a 10% premium, that has a lot of negative impacts as well. Besides the consumer, it means they're probably pricing higher than they should. They may drive good risk away. It keeps them from being optimally, it gets their risk profile out of balance. And so I think if you're an actuary, it's a big deal from their perspective as well. Those are some of the drivers. Does that help, Marco? Is that what you're poking at?
Yeah.
Cool.
There is a question. We are starting on the Memgraph deployment side as an integrator working with the government. What will be any do's and don'ts that you can share?
So is this the U.S. government, or I'm assuming?
I guess so. It might be. Yeah.
Yeah. So I'll give you a perspective. I think So first of all, as everybody knows, if it's the U.S. government, there are a number of different arms. So it's not one answer, unfortunately. But we have a separate panel where we talk about considerations for process, and I think one is compliance with OIG. That's the Office of the Inspector General. We have found OIG to be very cooperative, and happy to ping us offline. We've gotten to know those guys pretty well. They're exceptionally, how do we say this? They're servant leaders. They really want to help. They're very anxious to help. So I think the OIG, again, Office of Inspector General, is an important consideration. I also think understanding state insurance laws are really important. So there's a lot of friction if you're a secondary carrier around understanding what you can and cannot do. And that was in our panel. We didn't talk about it in detail, but there's always been an assumption that if Medicare pays, then we pay. And that's just not true. So there's that consideration to make sure that you're working with your legal team and you understand exactly what contract you filed with your various state insurance commissions. I think the other thing would be, again, in terms of explainability, I can't really overstate that. And this is a little bit of a shift to the fraud side when we're doing machine learning, but we do have to be cautious of data attributes that are predicting an outcome that are not unduly selecting a protected class, for example. So there's a real consideration around geography. You have to be very considerate and careful with geography or other factors. And you have to be really good about explainability. You have to understand and be able to tell a regulator why you did what you did, if that were ever to come into question. So again, pivoting a little bit more back to the fraud side, but I think it's also true in waste and abuse. You need to be able to defend what decision you made, why you made it, which again, why we talk about explainability so much. So go ahead, Satya, sorry.
No, Doug, actually the question was they are starting on Memgraph database, and his question was, what are the do's and don'ts for the Memgraph database?
I'm sorry, I took that as a
that's
government
okay.
regulation conversation.
Yeah, so let me try to answer that. I think the first thing that we need to be careful about is having or starting with a good model. As it's a best practice, I think, to understand what you want the graph to store and what you don't want the graph to store. I think deciding that is very, very important and critical. And if, for example, but the good thing is it is very flexible. Memgraph is very flexible, and it helps you change things without jumping through a lot of hoops. So that's what I actually like about Memgraph. It is a pretty flexible and easy to use, but I think it is a good idea always to start with a good schema, and that should have the relationships clearly defined, and also synonyms. Synonyms play a very critical role. So if the same term is being called by 5-6 different names, then you want to make sure that they are all going to the same node.
Yep, and I think that was from Dan. Yeah, sorry, I didn't have my Q&A panel open. Sorry about that. I took us down a rant on explainability.
No, that's okay.
Sorry about that. It's not that it's wrong, but that wasn't the question you asked.
Yeah.
Cool. Any final questions? I guess not. So thank you so much, guys, for the great demo. I think this has been great to dive into the fraudulent kind of aspects kind of it and the payments. And we're definitely going to do kind of a follow-up email. So if there's any questions for the guys, the attendees and the people would be able to kind of reach out. And thank you so much. And we'll be in touch on the interwebs. Thank you once again.
Thank you.
Right, all. Thank you. Take care.